Yes. Good afternoon to all. Yes, stop talking. Newcomers. How many of you are newcomers? Newcomers. इधर भी newcomers है ना? हाँ. उधर बहुत लोग हैं. हाँ. Newcomers है क्या? Okay. We are almost to the end. End of the semester, end of the subject, and you are new to us. Okay. Yes. Is the screen visible, everyone?
Yes.
Yes,
Yeah.
sir.
Okay. Fine. Already your friends have come to the college. So many people. In the online, there are only 18, including me, 18 people. Huh? Okay. Let's stop talking first. Okay. What all we have studied in the last class? We have started with the fourth unit. Okay. So what is that fourth unit? Surveying and remote sensing, and again that is GIS GPS. Okay. Everything. Surveying and geoinformatics. Okay. We are studying surveying in detail. Okay. Surveying, classification of surveying, principle of surveying. Yes. Last benches. What is the principle of surveying? Principle of surveying. How many principles are there in the surveying? There are two principles of surveying. What are those? Whole to apart, and one more is to locate a fixed point by taking at least two measurements from the reference point. Okay, so that is it. Then can you define what is surveying? It is an art of determining the relative position of a point which is on, above, or below the earth surface by direct or indirect measurements by measuring linear or angular measurements. Okay, so you have seen objectives, principles to locate a point by taking measurements from two reference points. Classification we have studied, different classification. Uses of surveying we have studied. Then coming to the geoinformatics. In the geoinformatics, how many techniques are there? Geoinformatics, how many techniques are there? 3. What are those? Yes, remote sensing, GIS, and GPS. Okay, you have studied in detail remote sensing. Again, in the remote sensing, how many types are there? In the remote sensing, how many types? 2 types. What are those? Yes, good. So there are 2 types. One is ARS and one more is PRS. Active remote sensing, and one more is passive remote sensing. Okay. So you have studied this one. Next. Okay, you have seen the working of the RS remote sensing. Applications of the remote sensing. In the exam, he may ask applications of the remote sensing if it is offline. Have you written assignments? I have given assignments, correct? Assignment 1, 2, 3, and 4. So advantages we have seen. Okay, these are the applications we have seen. Then coming to the GIS. What is expansion of the GIS? Geographical Information System. We are studying the information of the geography. Okay, that is Geographical Information System. So what are the components of the GIS? People, data, analysis, hardware, and software. Okay. Again, data structure. Output of the GIS is either graphical or alphanumerical. So what is the difference between graphical and alphanumerical? In the graphical, the picture of the particular object is visible. In the alphanumerical, the magnitude is visible. In case, consider there is a earthquake has happened. Okay, earthquake. From the GIS data, it will show in the graphic how much area is covered or suffered by the earthquake. How much area? Okay, that entire area is visible. But in the alphanumeric, how much impact of earthquake has occurred? It means impact scale is there, earthquake scale. So there is a Richter map. Okay, Richter scale. Through that scale, how much is the intensity of the earthquake has happened? That is shown in the alphanumerical. In the graphic, there are 2 types. One is vector and one more is raster. In the raster, again, area photographic and remote sensed camera. Okay. Then applications of GIS is very important. Yes. Now coming to the point of what is this one? GPS. Can anybody tell me what is GPS long form? Global Positioning System. These expansion is very important for your examination point of view. Okay, so global positioning system. I think you have heard this word and you have used this GPS in your mobile. Okay, what it indicates, what it gives, your location and your time, longitudes, latitudes. Okay, where your exact location is there, that it can be given from the this one person to the another person. Okay, first we will see today. What is GPS? GPS stands for yes, all the people have come. Huh? सब लोग आ गए F division students. Huh? Good. Okay, GPS is it is global positioning system. Okay, it is a radio navigation system. It is a radio navigation system used in land, sea, and air to determine the exact location. Yes, this point is very, very important. To determine the exact location, time, and velocity, irrespective of the weather conditions. Whether the condition of the weather is it a raining season or summer season or cloudy, or that is not matters. What it gives? It gives exact location, time, and velocity of a particular point. The US military first used in the era of 1960. This GPS has come into existence from the 1960, and who has discovered this one? From the US military. Okay, United States of America. Then components of the GPS. So GPS is a system and it is made up of three components. One is, see, components of the JS is what? People, hardware, software, analysis, and all. Okay. Similarly, there are components of the GPS, satellites, ground stations, and receivers. Okay. These are the important points. Okay. Write down first in your notebook. GPS. Are you writing, all of you?
Yes, sir.
Yes. Okay. So GPS is okay. Write it important. Okay. He is going to ask the expansion. Global positioning system. Global positioning system. So write down the definition. Definition. It is a radio navigation system. It is a radio navigation system used in land, sea, and air. To determine the exact location, time, and velocity, irrespective of weather conditions. Next point. The military, the US military means America, United States of America. US military, inside the bracket you can write America. First used in the year 1960. First used in the year 1960. Okay. Next point. Components of GPS system. GPS is a system. It is made up of three parts. Those are satellites, ground stations and receivers. Okay, in your multiple choice question, he may give which one is the not a component of the GPS system. He will give the satellites, he will give the ground stations, he will give the receivers, and he will give the one more people. So which one is not a people? Okay, of course, people includes receivers only, but here which one is not a? ऐसे पूछा था उन्होंने. So he may give which one is the following a component of GPS: satellites, ground stations, receiver, and all. All is the option. Okay. See, this is the ground station where the antenna is done. This is the satellite. Okay, he is the receiver. He is the receiver. If you want the location of the any particular point, okay, suppose if you are staying in the college, Ferry campus, your parents are there in your house. You have to give the location to. You have to send your location to your parents. How will you send? You will open the Google Map. You will send select your position and you have to send. Okay. So those are the what they are. Your parents are the receivers. Okay. Whatever you are sending, no, your mobile, that is your ground station, and satellites are there in the space. Okay. So whatever you are sending, that is the ground station, that will reach to the satellites first. From the satellites to the, it will reach to the receiver. So for what is the function of the each one? That is satellite, ground station, and receiver. So following are the functionalities of each of these parts. First one is coming to the point, satellites. Satellites act like a stars in constellations, and we know where they are because of they invariably send out signals. See, constellation is, it is a group of stars in the solar system. So there are different planets in the planet system, correct na? So entire solar system, there are different planets. Similarly, satellite says that it act like a star in the constellation. In the solar system, Earth is one part, one planet. Okay, Mercury, okay, and where Uranus, Neptune. So one planet is there. Similarly, satellite is a one part among the bunch, and they are because invariably send out signals. Then second one is ground stations. So they make use of radar to make sure the satellites are actually where we think they are. So whatever ground stations are, whatever, so by looking at the figure only you can judge. So satellites are there in the space. Whatever your signals are sending, so those are the ground stations. And receiver is, it is a device that you might find your phone in your car, and it constantly seeks the signals from the satellites. The receiver figures out how far away they are from the sum of them. Okay, don't worry about this whatever explanation is given. Just think that, so your parents are driving a car, they are in the car. Okay, you are sending your location to your parents. So you are what? You are the ground stations. Okay, where you are sending first? Satellites. The satellites, you know. Then that satellite captures your signals, and that will send to the person receiver. Who are the receiver? Your parents. Okay, so the whatever the mobiles are there, so they are continuously receiving the signals from the satellites. Okay, only these components you have to remember. You will come to know this one. Okay, how this GPS works? There are at least 4 GPS, at least 4 GPS satellites in line of the site of receiver on the Earth. So minimum is, there are sometimes 3 GPS will require, sometimes 4 GPS will require. So when 3 and when 4 we will study. The transmitter GPS sends the information about the position and the time to the receiver. Who are the transmitters? Who are the transmitters? Ground stations, satellite and receiver, correct? Receiver. So the transmitter GPS sends the information about the position and time. So you are the ground stationer. You are sending your location to your parents. Okay. So what you are actually sending? You are sending your location, time. Okay. the transmitter GPS sends information about the position. Location means position and time to the receiver GPS. Whatever GPS you are using, that is transmitter GPS, and your receiver is there, that is receiver GPS. The signals that are sent to the receiver devices are radio waves. Whatever you are sending, so the signals are in terms of radio waves. Okay, those waves are captured by the satellite, and those waves are sent by the satellites to the receiver. Waves are in terms of radio waves. By finding the difference in time between signals sent from the GPS satellite to the time the GPS receiver, the distance between the GPS receiver and the satellite can be calculated. See, you are sending the location now. Your parents are receiving at a time, they will receive, or they will receive after some time. After some time they will receive. So you know the timing and how much, you know the velocity. Velocity is received by the signals. And can you calculate the distance? Yes, velocity is equal to distance by time. Okay, you know time, you know velocity from the signal. So you can calculate the distance. How much is the distance? Using the trilateration process, the receiver locates its position as the signals are obtained from at least 3 satellites. Yes, whatever you are sending the location, it is not only one signal. It is continuously emitting your signals from the ground station to the satellite, and satellite to the receiver. Continuously it is sending. Yeah, it is not only one satellite. It is at least 3 satellites are required. Yes, this point is important. So for a GPS to locate a 2D position, which includes latitude and longitude, a minimum of 3 satellites are required. Yes, for a GPS to calculate 2D position, includes latitude and longitude, minimum how many satellites are required? 3 satellites are required. For a 3D position, that for a 3D position that provides latitude, longitude, and altitude. A minimum of 4 satellites are needed. Okay. Now, can you tell me what is latitude, departure, and altitude? So, if you take, this is the Earth surface. So, these are what? Latitude, correct? So, these are what? Longitude, correct? Vertical lines. For the 2D position, what are sent? Latitudes and longitudes are sent. So these latitudes and longitudes, how many satellites are required? 3 satellites are required. For a 3D position, latitude, longitude, and altitude. What is altitude? Height. Okay, the altitude is height. So 4 satellites are needed. Write down this point. Only last point is you can write down. For a GPS, for a GPS, for a GPS, to calculate a 2D position, to calculate a 2D position, 2D position, which includes the latitude and longitude, a minimum of 3 satellites are required. 3 satellites are required. Full stop. Next, for a 3D position, that provides latitude, longitude, and altitude, a minimum of 4 satellites are needed. 4 satellites are needed. Okay. See, if you want to send a location here, okay, if you want to send only latitude and longitudes, then how many satellites are GPS are required? 3 GPS. So one GPS is at the ground station, that is with your mobile, and one more GPS is with your receiver. Who are the receivers? Your parents. Okay, and one more GPS is there in the satellites. So if you want to send a 2D position, that is latitude and longitude, only 3. If you want to send the altitude also, one more GPS is required. How many GPS are required total? 4 GPS. Okay, how this GPS works? See, this GPS works a system of 30 plus navigation. Okay, so आपको understanding होने के लिए थोड़ा hard लगते हैं. Okay, just look at this one. 30 plus navigation satellites orbiting the Earth. We know their location precisely because they invariably send out signals. Whenever once the ground stations are sending the signals, that is continuously it is sending. Okay, and satellite is continuously receiving the signals and continuously emitting the signals to the receiver continuously. The GPS receiver in your mobile, in your phone, receives these signals once the receiver calculates its distance from 4 or more GPS satellites. It can be figured out exact where you are. Okay, so whatever the signals are sent by the ground stations to the satellites, from the satellites to the receiver receives the signals continuously. He is going to receive, from which you can calculate the distance. Okay, so there are at least 4 GPS satellites in line of sight of receiver on the Earth. The transmitter GPS sends the information about the position and the time to the receiver GPS at the fixed intervals. What is intervals? Intervals means what? Time. Okay, after every point, every 10 seconds or every 5 seconds, the transmitter sending the information to the receiver. The signals that are sent to the receiver devices are radio waves. So this point is important. Okay, in which format they are sending? The signals are in the form of radio waves. By finding the difference in the time between the signals sent from the GPS satellites to the time the GPS receives, the distance between the GPS receiver and the satellites can be calculated. Okay, when you are sending the signals to the satellites, okay, there is a time is required. Okay, from that time to the receiver, how much time required? Okay, so that is calculated. From the time you can calculate the distance also. Using the trilateration process, the receiver locates its position as signals are obtained from at least 3 satellites. For a GPS to calculate a 2D position, which include latitude, longitude, minimum of how many satellites? 3 satellites are required. For a 3D position that provide latitude, longitude, and altitude, minimum of 4 satellites are required. Okay. Same thing. See, what is this trilateration means? Trilateration is nothing but is the screen visible, everyone?
Yes, sir.
Yes. Okay.
Yes.
Okay. So what is this trilateration? Trilateration is defined as a process of determining the location based on the intersections of the 3 spheres. See, you are sending the signals to the pair satellites. Okay, satellites to where it is coming? Where it is coming? It is coming to the receiver. Okay, receiver. So the signals are continuously, there are minimum 3 satellites. Okay, 3 signals. Trilateration is defined as the process of determining the location based on the intersection of the 3 spheres. The distance between the satellites and the receiver is located by considering a 3D sphere such that the satellite is located at the center of the sphere. Using the same method, the distance for all the 3 GPS satellites are received and calculated. Okay, so this is the accurate one. Okay, so just you remember this one. Trilateration process. Okay, this is not required. Frequently asked questions. Yes, this is what you have written already. What are the questions that is going to ask in your exam? So first one is, what is GPS? What is GPS? It is global positioning system. Global positioning system. It is a radio navigation system used in land, sea, and air. For what purpose? To determine the exact location, time, and velocity, irrespective of the weather condition. Okay, this is the first question he is going to ask. What is GPS? Then, what are the 3 components of the GPS? What are the 3 components? Satellites, ground stations, and receivers. You remember this one. Okay. Then, how the GPS works? By finding the difference in the time between the signals sent from the GPS satellites to the time GPS receives. Okay, time difference is important. Difference in the time between the signals sent from the GPS satellites to the signals received from the GPS receiver. The distance between the GPS receiver and the satellite can be calculated. Using the trilateration process, the receiver locates its position as the signals are obtained from the at least 3 spheres. This is important question. Then what is trilateration? So trilateration is defined as the process of determining the location based on the 3 intersection of the spheres. Okay, first one satellite is there, iska sphere is there. Another satellite is there, iska sphere is there. Third, there will be one more satellite and iska sphere. So intersection of all the 3 means this portion. The process of determining the location based on the intersection of the spheres. Name the parameters that are calculated after the trilateration. The following are the parameters are calculated after the trilateration. First one is time of sunrise, sunset. Okay, so from this one only you can calculate the GPS. When the sun is going to rise, when he is going to sunsets. From the weather forecasting, he is going to tell, okay, tomorrow sunrise timing, so it's sunset time. Okay, if there is a rain will come tomorrow or not. Okay, from the weather forecasting, so they are depicting the timing based on the GPS only. Speed, distances, okay, all these are from the GPS. Then applications of the GPS, where GPS is actually used. Due to the high accuracy, versatility, and ease and economy of the operation and all weather operations offered by the GPS, it has found that numerous applications in many fields, ranging from level to the high precision geodesy to the several meters level navigation positioning. So in order to determine the accurate value, we are using the GPS application. So first of all, first one is establishment of the high precision zero order geodetic navigational survey control network for GPS stations. High order precision means what? High order precision. So if you consider Earth is very large. Okay. If you consider earthquake, if it occurs only small portion, it is affected. By considering the entire Earth, earthquake is going to happen at only small portion. Okay, from the GPS you can calculate the accurate. So what is the length in terms of also, in terms of micron also, it is going to calculate how much is the crack width, how much impact is the earthquake. Everything can be calculated from the GPS. Strengthening, densification, and readjustment of the existing primary control network using GPS stations. So primary control network means whenever you want to do the survey work, first of all, you have to fix the point. Those points are called as primary control points. Okay. So while doing the survey work, first of all, we are dividing the entire area. Okay. So first point is nothing but your primary control points. So that point is strengthening, densification, and readjustment of the existing primary control network using GPS station. Then connecting remote islands to mainland geodetic control network. So remote island means, so you have seen India map and you have seen Andaman Nicobar. Okay, where is Andaman Nicobar? They are islands, correct? They are very small, minute islands as compared to the India. But they are connecting between the Andaman Nicobar to the India. So that is connecting remote island to mainland by using geodetic control networks. Then determination of the precise geoid using GPS data. Geoid means how the earth shape is, how it is. Is it exactly sphere, exactly circular? No, it is spheroidal shape. Okay, so geoid means something which is similar to the sphere, that is called as geoid. Determination of the precise geoid using GPS data. This is one of the application. Then earth rotation, polar motion studies from GPS data. So how the earth is rotating? It is rotating from east to west or west to east, and what is the speed? That entire thing is calculated from the GPS data. Then estimating the gravity anomalies using GPS. Yes, anomalies means something which is trying out from the standard value. So what is the G value? Standard G value 9.81. If at all due to the some other effect, G value is fluctuating 9.61 or 9.91. Okay, the parameter which are deviating the standard value, those are called as anomalies. Okay, estimating the gravity anomalies using GPS. Okay. So these all are the some of the applications. Then in the marine geodesy they are using, then earthquake monitoring they are using, vertical control network they are using, geophysical positioning system, offshore position. Offshore means what? Offshore. When you are in the marine, okay, when you are doing a, when you are in the sea, okay, ship, okay, when you are in the full, this is water, there is a ship, okay. If you want to get the exact location, you can use the GPS. During shipping, offshore platform, fishing, boating, okay, at that time you are using offshore GPS. So these all are the applications of GPS. Yes. Now coming to the point, what is the difference between the GIS and GPS? Why you are laughing? Huh? Okay, what is the difference between this one? What GIS will give and what GPS will give? GIS will give the earth information, geographical information, correct? And what GPS will give? It will give exact location of a particular person. Okay, particular person. See, first of all, you should know meaning. So GPS is a satellite-based radio navigational system that tracks down an exact location on the Earth surface. Exact location, that is from the GPS. And GIS. GIS is a system that provides analysis and information of the geographical data. Yes, geographical data is important. Okay, these are the important. Okay, in your exam, he is going to ask. Okay, write on this first point. Differences between GPS and GIS. Yes, all of you, write on these points. These are important. Make a 3 columns. First one is parameters. First one is parameter. Second one is GPS, and third one is GIS. First one is write the definition, meaning. What is GPS means? GPS is a satellite. Are you reading, all of you?
Yes, sir.
Yes, okay. GPS is a satellite-based radio navigation system. Satellite-based radio navigation system that tracks down an exact location, an exact location, an exact location on the Earth's surface, on the Earth's surface. In place of GIS, GIS is a system that provides analysis and information of geographical data. Geographical data. Next point, etymology. Etymology means when it is discovered and who has discovered. Etymology. US department in GPS. GPS is discovered by US department. What is US? United States of America. US Department of Defense. Department of Defense in 1978. In 1978 launched its prototype. Prototype means what? Prototype. So there is a spherical-ish. Okay, ऐसे एक मॉडल बना सकते हैं ना पेपर में, ग्लास में. Okay, that is called as prototype. Okay, that is duplicate. Okay. US Department of Defense in 1978 launched its prototype spacecraft known as the GPS project. Then in GIS in 1963, Rogers Tomlinson's along with the Canadian government invented GIS to maintain a manageable inventory of natural resources. Then applications. GPS application to locating positions, getting access to emergency roadside support, preventing automobile theft and mapping and surveying Then GIS applications are mapping, transportation and urban surveying, natural resources, risk and disaster management, agricultural value chain, and public health analysis. Okay, in all those fields we are using GIS. See, in the GIS, GPS, there is one point, preventing automobile theft. It means what? If you are somewhere you are standing your bike, okay, you are parked in a non-parking area. You have parked your vehicle. You have kept your GPS on. Okay, so someone has came and he has taken away your bike. Then can you find out where he is there? Yes, using the GPS location, you can find out where is exactly your vehicle is there, because you are fixed the GPS. Correct, na? In that case, we can. Okay. Yes, is it completed, all of you?
Yes, sir.
Yes. How it works? This is one more. Okay, this is the last one. So in the GPS, atomic clock, atomic clock is installed. Atomic clock is installed in GPS satellites. In GPS satellites, where broadcasting can be determined by the receiver the satellite embeds time information. The satellite embeds time information. And coming to the geographical information system, GIS is a computer based system that stores, analyzes, displays geographical data of the earth's surface in shared drive files. Shared drive files. So these are the some of the differences between GIS and GPS. So in the exam, he is not going to ask all these things. What he is going to ask? What is GIS? What are the components? Okay. Then application oriented. Okay. That's all. In the GPS components, what is GPS long form? GIS is GIS long form and its components. Okay. That's all. In the remote sensing, what is remote sensing? What are the types? Okay. And how it works? That is a theoretical question. And coming to the surveying. So what is surveying? Objectives, principle, classification based on. Okay. So these all are the some of the. Okay. So this completes entire basic civil engineering. I am not telling BCME. I am telling only basic civil engineering. Okay. That is basic civil and mechanical engineering. BCME 1 you can call. Okay. So that's all from my side. If you have any doubt at any point of time, you can ask me now. Yes. Is there any doubt? When is your IIC? UT3? कल है ना? BCME कल? आज? BCME? No, I think Wednesday, Thursday or Friday? Friday, right? Today, BCME. I have not prepared. I have not prepared. Still your paper. Okay. Now only I will prepare. Huh? What are the chapters? Have I uploaded the MCQs on this one? 4th chapter. Upload किया?
Yes, sir.
देखा है ना? Okay.
Yes.
I have uploaded the MCQs and assignments from the chapter number 1, chapter number 2, 3, 4. Just a minute. Yes, it is there. This is all from my side. I have taken all the lectures, all the points. If you have any doubt, you can ask me. Assignment 1, assignment 2, assignment 3, assignment 4. All 4 assignments I have uploaded. Correct? And coming to the MCQs, unit 1, unit 2, unit 3, and unit 4 I have uploaded. Correct? Yes, all of you. So ISC 2 was on unit number 2 and 3. Correct? 3 लिया था क्या नहीं? अभी UT3 will consider 3 and 4. Is it okay? UT3, 3 and 4. Only I will ask how many questions? 20 or 15 questions? 20, 10 questions है ना? 10 questions BCM1, 10 questions BCM2. Okay, I will consider chapter number 3 or 4. कौन सा question? ISC 2 को chapter number 2 consider किया था ना? ISC 2 को किया था. So I will go through the questions on this 4th unit. We will see this and this both. Okay, I have the lecture at 3 to 4. 3 to 4. So we will discuss some of the MCQ questions. Okay, so now this completes entire your syllabus. So in the next class 3 to 4, I will take one lecture and I will discuss all the multiple choice questions. Is it fine, all of you?
Yes, sir.
Yes. Okay. So now we'll stop. We'll continue the next lecture. So I will take attendance now. Roll number 1. Who is 1? First. Okay. 2 present. 3. 3. Okay. 4, 5, 6. 6. 7. 7. 8. 9. 10. 11, 12. 12. 13, 14, 15, 16, 17, 18. 18. 19. 19. 20. Roll number 20. 21. 23. 25. 25. Sleeping. 26. Who is 26? 27. 27 absent. 28. 28. 29. 30. 30. Who is 30? 31. 31. Okay. 32. 33. 33. 34. 35. 37. 37. 38.
Present, sir.
39. 40.
Yes, sir.
40, 41. 42. 42. 43, 44, 45, 46. 47. 48. 50. 50. Who is 50? 51. 52.
Present, sir.
53. 54. 55. 56.
Present.
56. 61. Okay, absent numbers 12, 18, 20, 27, 37, 56, 61. Okay, these are the absent numbers. 60 present. Okay, we'll stop now. We'll continue in the next lecture.